Okay. So the scatter plot is that it's working with 1990, 91, 92, 93, 94, 95, 96. Instead of doing 1,991 or something, what I decided to do was, actually we could go with, 91, 2, 3, 4, 5, and 6. And so this is 1990, and then that's your start. It's 1990. And then it goes 91, 92, 93, 94, 95, 96. And then going up, we're just going to go from 0 to 11. So in 1990, we have 11, right? And in 1991, we have 10 and a half. And in 92, we got 8. So 10, 9, 8. Okay. In 93, we have 9. In 94, we have 7. In 95, we have 6. In 96, we have 4. Okay? And we have these plots. And now we want to create a line of best fit. We also want to know we want to know the correlation and the R value. Okay? The easiest way to do this is to look at the correlation first. Is this going down or is this going up? Is this down, right? So this correlation is negative. So it has a negative correlation. That means the R value is going to be negative. Now, how close of an R value? Well, I could keep it simple and do that, right?
Negative 0.8.
And when I look at it, it looks like about 0.8, 0.9. I'd say 0.8 is fair, right? Negative 0.8. Okay? Now, if I want to find the line of best fit, right? I want to look at this and look at where I'm going through some vertices, right? I cut the thing in half. Half of the points are on the line, half the points are above the line, half the points are below the line, right? So I kind of want to look at the differences of what's going on. And remember, this is 0 to 6, or really 1990 to 1996, right? So what is the difference between, let's say, we could look at this point. Let's do it in a different color. We could look at this point, which isn't a point, right? And this point, which is a point, I guess. And we can look at this and go, how far apart are these? How far apart is 2 from 4? 2. So x is, the difference in x is 2. How far apart is 6, 7, and 8, 9? How far apart is 7 and 9? 2. So the difference in y is also 2. So if slope is the difference in y over the difference in x, then the slope is going to be 2 over 2. But I'm going down 2, right? So it's negative 2 over 2. So what is negative 2 over 2? Negative 1. So we have the slope is negative 1. And then we want to find the y-intercept. Where would the y-intercept be? Now it looks like the y-intercept is 11, right? Right, guys? It looks like the y-intercept is 11. But you have to remember, this is in 1990 right? So we're going to take a couple of these points. One of the points is in 1992, right? In 1992, the y is 9, right? So when I plug that in to y equals mx plus b, then I get y is 9 is equal to m, which is -1, times 1992 plus b. What is negative? That's just negative 1992, so negative 1992 plus b. Then I'm going to add 1992 to both sides. And I get 2,000.
Can you do it, Dan?
And how much?
I don't know, you told me there's an app to just. Oh, there you go.
Woo! Okay? And so, my new equation is going to be y is equal to -1x, or negative x, plus 2001. Okay?
The distance for 1992 is, or the rate is 8.
The what?
The rate,
The rate?
yeah, it's not 9. It's 8.
Uh-oh.
You were looking at the other one. 93 is 9.
Did I plug it?
Found it.
Oh, no.
No.
I created my own rate, remember? I created my own from the line,
Oh, yeah.
right?
It's the same thing.
So I was just taking a point on the line and looking at it as a point on the line. So it might not fit one of the actual points. That's okay. What matters is that it's a point on the actual line. So we don't care if any of the points are on the line. Some of them are going to be above it, some of them are going to be below it. Most of them shouldn't be on it, but in this case, a couple of them ended up being on it. These two ended up being on it. But that doesn't happen very often. Does that make sense? And then you use 2 points. We could have technically used these 2 points, but then that would be confusing. I don't want you using points that are being used. Does that make sense? I want you to create your own points from a line that cuts the graph into 2 pieces. Half of the data is below the line, and half of the data will be above the line. Good?